So here we are on How Do Power Meters Work, part 8 of 10. So how do we measure resistance? Well, remember, we talked about this at the very beginning. Voltage is equal to the water pressure and current is equal to the water flow, okay? So, and just like a water circuit, you cannot measure the resistance of the pipe. You can't just take some kind of special meter up there and measure the resistance of the pipe. You have to apply a water pressure and measure the flow rate of that water. And then you can calculate the resistance of the pipes, right? The amount of restriction that you have. So it's the same thing with resistance measurement for electrical circuits. You have to apply voltage and measure a current. Okay. So how do we do that? So if you had a live circuit, you would be able to do this, right? All you would do is say, I have a battery applied, some DC voltage, and then you would just measure the current going through the load, right, which is your resistor, and just measure the voltage drop across that resistor. Divide those two out, and that would give you the known resistance, okay? But how do you do it in a de-energized circuit, right? If I didn't have this battery here, right, how would I do it? Well, why don't we just install our own battery on the circuit, right? And you can see that these arrows right here are your test leads, okay? So this is the resistance that we're measuring right here. And this is what the old Simpson meters did for the most part. They didn't need a 9-volt battery in them to operate the voltage measurement or the current measurement. They needed the 9-volt battery in them so that way you can operate the resistance measurement circuit, okay? And that way you can accurately measure resistance. So this is how it would appear using the same full scale D'Arsonval meter that we were using in all the other ones, right? Which is 500 ohms with a full scale deflection of 1 milliamp, okay? So what we're saying is if this circuit passes 18 milliamps through it, well, in this situation, that would probably burn up this meter. Okay, so you wouldn't really want to pass these 18 milliamps in series through the same meter that's only rated at 1 milliamp. Okay, you would practically smoke it, but you could do some calculation. You do know that the resistance of the meter is 500 ohms right here, and that's in series with our resistor. So we have a voltage right here and a current. So 9 volts divided by 18 milliamps is equal to R plus 500 ohms. See how we're doing that? And if you do the 9 volts, let me pull out my little 9 divided by 0.018, you're going to get 500 ohms, okay? And so that means 500 ohms is right here, equals R plus 500. And as you can see, the 500 cancels out on both sides and R equals 0. Okay, so this isn't really practical for the most part because we do have resistance of our leads and everything else, but that's how you would do this, okay? So the same situation applies for a multiple selector, like we did with the current and the voltage meter. This adjuster is just for calibration. Don't really pay any attention to this, but we're going to apply a voltage like it's shown right here, and then we're going to measure the current just like you would any other way that's going through it. Okay, and the meter right here is really current deflection. It's how much current is generated through this meter. And you're going to allow some parallel to go through here, okay? And so when you use these scales, these allow you to measure larger and smaller resistors. For the most part, it's very similar to how the voltage circuit was set up, okay? And this adjuster, like I said, is just for calibration purposes. This voltage source was provided previously by the voltage source that we were measuring. Now we have to provide it internally. And if for more demos on this, you can see here is a image that I captured from one of my other videos. I have two multimeters plugged into each other, and one of them's set to resistance, and it's metering 10.58 mega ohms, right? So this one is 10.58 mega ohms. That's the input impedance of those leads. Okay. These right here are 10.5 mega ohms. Okay. That's what it's measuring. And then this one right here is set to voltage, and it's measuring 2.715 volts. That's measuring the output from this one right here, which is trying to measure resistance. So it's trying to measure resistance. It is measuring this one's resistance, but in the process of doing that, it's applying a voltage, and this meter's measuring it. Okay, so that's demoed in this video right here. And if you want to type that in or look it up, it's contact resistance. I believe it's number 6 out of the series.